To do the cross product, which is a different procedure performed on vectors that we're going to use to find things like areas of parallelograms and triangles. It's used in upper level physics computations. We're going to find something called the volume of a parallelepiped, which sounds really cool. We're going to have to use a process that we learned with matrices called the determinant. We started by learning this thing called the determinant. It looks like a matrix, except that instead of being between braces, it looks like it's between absolute value bars. To find the determinant, you would multiply A times D and subtract from it B times C. And it needs to be done in that order. It's very, very particular. Well, this is a determinant of order 2. We're working with vectors in 3 dimensions. So now we're going to talk about what happens when you have a determinant of order 3. The way that this works is you start by taking A and you multiply it by the determinant of this, so EFHI. And then you subtract from it B, so we have alternating signs. We're going to use the determinant DG because that's to the left-hand side of B, and FI because they're to the right. Notice that I just didn't pick the letters underneath of it. And then we're going to alternate again and do plus C and do the determinant of DEGH. I picked those 4 because they were not underneath of C. And again, when you go to do this, you have to multiply in a very particular order. You have to do EI minus FH. The multiplication part, that's not the part that matters. I could do IE minus HF. But the subtraction is very important. Then minus B, DI minus FG, plus C, DH minus EG. Now for vectors in 3 dimensions, one of the rows of our matrix is going to be IJK, which are the unit vectors. So the final answer to a cross product is going to be a vector as opposed to when we did a dot product and it was a scalar. So let's do an example where we find the cross product of A and B. Vector A is 0, -1, 3. Vector B is 2, 0, -1. So in order to find the cross product, we're going to start by writing IJK in our first row, 0, -1, 3 in our second row, 2, 0, -1 in the third row. First, I'm going to do I times the determinant of -1, 3, 0, -1, because they're not underneath of I, minus J times the determinant of 0, 3, 2, -1. Again, I picked the numbers that were not underneath of J, plus K and the determinant of 0, -1, 2, 0. Now I'm going to do the determinant. I'm going to do 1 minus 0 minus J, 0 minus 6, plus K, 0 minus -2. Make sure when you do your cross multiplication, the little thingy here, watch your signs. So I'm going to get 1I plus 6J plus 2K. And that is the vector answer for the cross product. The vector A cross B is orthogonal to both A and B. Remember that orthogonal meant perpendicular. Also, if you do a cross product and you get a 0, the vectors are parallel to each other. Unlike with the dot product is equal to 0 when they were perpendicular. So let's do another example. In example 2, vector A is going to be negative j plus 3k, and vector B is going to be 2I minus k. I want to find a unit vector that is orthogonal to the plane containing these two vectors. In order to do that, we're going to do the cross product of A and B and divide it by the magnitude of the cross product. So basically I need to find the cross product and then I need to figure out what its magnitude is and just divide it. So let's start with the cross product. I, j, k go in the first row. Vector A is 0, negative 1, 3, because there's no I component, so it has to be 0. And vector B is going to be 2, 0, negative 1. So I'm going to get I. Now I'm going to start skipping steps. The cross product of this is going to be 1 minus 0. Then I'm going to do minus j, and I'm going to do the cross product of this. So I'm going to get 0 minus 6 plus k, and now I'm going to do the determinant of this. And I'm going to get 0 minus negative 2. So the cross product is going to be 1i plus 6j plus 2k. Then I'm going to find the magnitude of that. The magnitude of that vector is going to be the square root of 1 squared plus 6 squared plus 2 squared. That's going to be the square root of 41. So the unit vector perpendicular to the plane containing these two vectors is just going to be I plus 6j plus 2k divided by the square root of 41. And there's really not a lot you can do with that to simplify it. You can put the square root of 41 under each term if that makes you happy, but that's about all you can do with it. What if I want to find a vector perpendicular to a plane? Let's say that I give you 3 points on a plane. P is 1, 4, 6. Q is negative 2, 5, negative 1. And R is 1, negative 1, 1. In order to find the vector perpendicular to the plane that passes through these 2 points, I need vectors. And P is normally our initial point, where Q is going to be a terminal point, and so is R. So we're going to find vector PQ first. Remember, we do that by doing terminal minus initial, terminal minus initial, terminal minus initial. We're going to find vector PR, terminal minus initial, terminal minus initial, terminal minus initial. Now we're going to find the dot product of those two. Let's try that again. We're going to find the cross product of these two vectors. The cross product is going to give me a vector that's perpendicular to the plane passing through these points. I, j, k, negative 3, 1, negative 7, 0, negative 5, negative 5. All right. I'm going to start with I, and then it's going to be negative 5 minus 35, minus j, 15 minus 0, plus k, 15 minus 0. So I'm going to get negative 40i minus 15j plus 15k. Now, this is not the only answer. Any multiple of this answer is also a vector that is perpendicular to the plane passing through those points. So if I want to multiply each of these components by the same value, or I want to divide each of these components by the same value. I will get another vector that is also perpendicular to that plane. The length of a cross product. Length, remember, is the same thing as magnitude. Well, what if I want to find the magnitude of a cross product, but they didn't tell me the vectors, but they did tell me the magnitudes of the vectors and the angle between them? Well, I can find the length or magnitude by also using this formula. The magnitude of A times the magnitude of B times the sine of the angle between them. And as I had said earlier, if the cross product is 0, then the two vectors are parallel to each other. The area of a parallelogram, which you know is base times height, can be found using a cross product. It's just the cross product of two vectors. So if I have two vectors in 3 dimensions and I want to find the area of the parallelogram, I just do the cross product of those two. Well, what if instead of finding the area of a parallelogram, I wanted to find the area of a triangle whose vertices are in 3 dimensions? Well, the area of a triangle is just 1/2 base times height. So it really just must be 1/2 the magnitude of the cross product. That's it. So in example 4, we're going to find the cross product of two vectors defined by these points. And we did this earlier. We already found that PQ was -3, 1, -7. And we found that PR was 0, -5, -5. And we already found the cross product in problem 3. So we already had found out that it was -40, -15, 15. So I'm going to skip that part. So now in order to find the area of the triangle, the first thing I'm going to do is the magnitude of this would be the area of the parallelogram. So the magnitude of this would be -40 squared plus -15 squared plus 15 squared, which is going to be the square root of 2050, which is a big number, so it's kind of hard to simplify that radical. So I'm going to tell you what it is. 2050 is the same thing as 25 times 82, so it's going to be 5 the square root of 82. But that's the area of the parallelogram. In order to find the area of the triangle, you have to do 1/2 of that, which is just 5/2 the square root of 82. So in order to find the area of that triangle, we first had to find the vectors PQ and PR. We performed their cross product. We found the magnitude of that cross product, and we took that answer and multiplied it by 1/2.